Welcome to IIQA. If you are an instrumentation personnel involved in commissioning and industrial automation, this video is going to level up your knowledge fast. Today, we are covering 20 powerful must-know commissioning questions and answers, essential knowledge for every instrumentation commissioning professional. These are the questions that show up in interviews, site troubleshooting, loop checks, DCS PLC commissioning, and real plant operations. Let's jump straight into the video. Let's go. What is the primary role of an instrument commissioning engineer? Their primary role is to verify, test, and calibrate all field instruments and control systems. They make absolutely sure that everything is installed correctly, functioning exactly as the design intended, and, most importantly, ready for safe operation before the plant is handed over. What is loop checking in commissioning? Loop checking is the process of verifying the entire signal path. It ensures that every element, from the field sensor to the control system display, operates correctly, including proper wiring, accurate signal scaling, and acceptable response time. What documents are required before starting commissioning? Approved piping and instrumentation diagrams, the instrument index, detailed loop diagrams, wiring drawings, I/O list, and the cause and effect matrix. These documents tell us what should be installed and how it should behave. Plus, you absolutely must have the signed-off pre-commissioning checklists. How to ensure instrument installation quality? Through physical inspection. Check for correct orientation. Is the flow meter facing the right direction? Is the instrument properly tagged? Then verify impulse line routing, proper cable termination, and gland sealing. If anything doesn't match the IFC issued for construction drawings, it's a fail. Quality first. What is the purpose of a FAT and SAT? FAT stands for Factory Acceptance Test. This is done at the vendor's shop. SAT is the Site Acceptance Test, done after the system is installed at the actual plant. Both ensure the control system hardware and software meet specifications, but they happen at two very different locations. How to handle the calibration of instruments? Calibration is non-negotiable. Use certified, traceable calibration equipment. This is essential for legal compliance and accuracy. The process involves adjusting the instrument's zero and span against known standards. Most importantly, always record the as found reading, how it was, and the as left reading, how we left it, to document any performance changes. What is a cause and effect test? A cause and effect test is a key safety check for industrial control systems, especially the safety instrumented system. It ensures that when a hazardous event happens, the safety instrumented system responds correctly by carrying out the required safety action to protect people, equipment, and the plant. What steps are included in pre-commissioning? Pre-commissioning takes place before power is applied to the system. It focuses on physical readiness checks to ensure everything is safe and prepared. Typical steps include performing visual inspections, testing cable integrity with a mega test, checking continuity of connections, conducting leak tests on impulse tubing, carrying out preliminary instrument calibration. A well-executed pre-commissioning process makes the actual commissioning phase much easier and more reliable. What are the responsibilities of a commissioning supervisor? A commissioning supervisor manages the commissioning teams, ensuring everyone adheres to the schedule. Their job is coordination, working closely with the construction and operations teams. They are also responsible for rigorous safety compliance and ensuring all technical issues are solved quickly to maintain progress. How are instrument faults addressed during commissioning? When a fault occurs, structured troubleshooting is applied. The root cause is identified, whether related to the instrument, wiring, or configuration. Field wiring is verified, signals are checked at the marshalling cabinet, and configuration settings are confirmed in the DCS. If the issue is physical, coordination with the construction team is required for rework. The final critical step is to retest the entire loop after the correction is completed. What is an inspection and test plan? An inspection and test plan is a document that shows how quality will be checked during a project. It explains when inspections and tests should happen, how they will be done, and who will be present, like the client, contractor, or another party. It also lists the rules or standards that must be met before work is accepted. In short, it makes sure every step is properly checked and approved. How are safety standards ensured? Safety is the top priority. Everything starts with following the site's permit to work system and ensuring all energy sources are properly isolated before any activity begins. Safety integrity level requirements guide the reliability of the safety systems, and functional safety logic is verified through controlled testing to confirm correct operation and protect both personnel and assets. What is I/O loop check and functional verification for DCS PLC systems? I/O loop check and functional verification for DCS PLC systems is the process that connects the field instruments to the control room. It involves verifying every digital and analog input-output point in the distributed control system (DCS) or programmable logic controller (PLC). The correct signal type, such as 4 to 20 milliamps, range, scaling, and alarm limits are checked. The instrument's signal is confirmed to be accurately translated and integrated into the control system so that operators receive the correct data. Why is proper documentation important in commissioning? Documentation serves as proof of work completed. It provides traceability, allowing future reference to who performed tests, when they were conducted, and how they were carried out. Proper records ensure quality assurance, compliance with regulatory standards, and enable a smooth, efficient handover to the operations team. Inadequate documentation can result in significant problems later in the project life cycle. What is a punch list and how is it managed? A punch list is a record of incomplete or defective items identified during inspections and testing. These items are common in projects but must be systematically managed. Each entry is tracked, assigned to the responsible discipline, such as construction, electrical, or instrumentation, and resolved through corrective action. Formal clearance is required for every item, with the ultimate objective of achieving a zero-punch list status prior to final handover. What is hot commissioning? Hot commissioning is the stage where instruments and control systems are tested under actual operating conditions. Unlike cold commissioning, which relies on simulated signals, hot commissioning takes place after utilities are online and real process fluids are introduced. During this phase, instruments measure live parameters such as temperature, pressure, and flow, and system performance is verified in the real environment to ensure safe and reliable operation. How is instrument signal scaling ensured in DCS PLC? Correct scaling ensures that operators view accurate values in the control system. The instrument's calibrated range, for example, 0 to 100 psi, is compared against the configured range in the distributed control system, DCS, or programmable logic controller, PLC. A known signal percentage is injected or simulated, such as 50%, and the human-machine interface, HMI, is checked to confirm that the displayed engineering units match the expected value. Alarm and trip limits are also verified to ensure they correspond correctly to the instrument's operating range. How is coordination with other disciplines, mechanical, electrical, achieved? Commissioning requires close collaboration among all disciplines. Coordination with mechanical and electrical teams is typically maintained through regular meetings and communication channels. Instrumentation activities often depend on mechanical completion, such as pipe testing, or electrical completion, such as power availability. Interface issues, where the work of one discipline affects another, are identified, tracked, and resolved to ensure progress remains aligned with the overall schedule. What challenges commonly occur during commissioning? Commissioning frequently involves a set of recurring technical issues. Typical challenges include incorrect field wiring, resulting in faulty signals or non-operational equipment, improper instrument range or scaling in the control system, leading to inaccurate process indications, communication faults between devices, networks, or engineering teams that slow down progress, incomplete or outdated documentation, which complicates traceability and troubleshooting. Effective commissioning requires quick problem identification, clear coordination among all disciplines, and a structured approach to root cause analysis. After corrective actions are implemented, all affected systems must be retested to confirm proper functionality and ensure long-term reliability. What is the process for system handover? System handover is the final phase of commissioning and involves the formal transfer of the system from the project team to operations. The process typically includes completion of all functional and performance tests to confirm the system operates as intended, closure of the punch list ensuring all defects, pending items, and non-conformities are resolved, compilation of the handover dossier, including test reports, certificates, calibration records, and supporting documents, securing all required approvals from the client, authorities, or third-party inspectors, updating drawings and documents to as-built status, accurately reflecting the installed configuration, formal transfer to the operations team, often accompanied by operational and safety training. The objective is a seamless transition, ensuring the plant is fully operational, compliant, and ready for continuous service. Thanks for watching. Please subscribe, like, share, comment. IIQA